Mr. Claxton's Algebra 1 CP, or Algebra 1, or Algebra 2 CP for that matter, class. I would like to come back to you again here with a better drawing. Notice that better drawing. If you watched the first video, which was about 7 minutes, it was a pretty sloppy drawing. After many attempts, I have drawn this example right here of the exponential function. Notice how it goes forever up, and then it goes forever to the left that way, where it's going to get very close to that x-axis, but it's never going to touch it. Okay, never going to touch it. You'll learn in Algebra 2 CP that that's called an asymptote. Okay, whenever that happens, it gets so close to it, but it never touches it. Over here, the first thing I'm going to determine is this exponential growth or exponential decay? Notice how we looked at the base and the exponent. The exponent only tells us that it's an exponential function, the variable in the exponent. So, yes, we know that it's an exponential function, obviously. And then the base is in between 0 and 1, and because that base is in between 0 and 1, we know that this is going to be exponential decay. Okay, decay, which means it's going to approach 0 as it goes to the right. This particular one is going to approach 0 as it goes to the right. So, down here, I'm going to go ahead and erase a little bit of what I've done before. Down here, I'm going to show you how to show work. Show you how to show work. Oh boy. We're going to draw a table again. So draw a quick table. And what I'm going to do is I'm going to go ahead and pause to save you time and me time. I'm going to go ahead and pause and create that table, and we'll be right back with that table. And magically, you can see I've listed all these x values that I would like to test. Those points are x values, right? And they will give me an output, or a y value. You could also call that y value f of x. Okay, we need to get used to calling that f of x. You Algebra 2 students already know that. That's f of x. That's f parentheses x. And what I've done here, you notice up here in green, I've rewritten this exponential function. I've rewritten 0.1, or 0 1/10 raised to the x power, as 1 over 10 raised to the x power. I know that 0.1, or 1/10, is the same as 1 over 10. And that helps me a lot in figuring this out. I don't need a calculator. I'm smarter than a calculator, right? We all are smarter than a calculator. So let's go down here and let's take a look at why this is going to help me. I chose this green form, not only because it looks beautiful, but because it's going to help me to manipulate the numbers without a calculator. I know that anytime that I have a negative exponent, okay, that negative exponent almost means inverse. And what inverse means is just the opposite, right? Inverse and reciprocal should be synonymous, okay, with your vocabulary right now. So we're going to just go ahead and flip this. We're going to take the reciprocal of everything in the parentheses, and when I take the reciprocal of everything in the parentheses, I can raise this now. Remember, math's about balance, okay, and counterbalance. So because I just did that in here, I can now write this to the 5th power. And boy, that gives me 10 to the 5th power. And 10 to the 5th power is just much easier to calculate. I know that 10 to the 5th power, and many of you know that 10 to the 5th power is just a 1 followed by 5 zeros. A 1 followed by 5 zeros. Whoa, Mr. Claxton, got ahead of myself there. Oh. There we go. So we got the 1 followed by 5 zeros. Okay. All right. So the 1 followed by 5, that's 100,000. Well, let's go ahead and graph that up. Oh, wait. Oh, Mr. Claxton, it goes by ones here. 100,000 would be, yeah, that would be all the way up into Mr. Johnson's room. So I can't graph that. I just know that at the -5th, yeah, that's going to be all the way up. I could go up in Mr. Johnson's room and draw a point, but I'm not going to do that. So I'm just going to kind of work my way down here. I know that 10 to the negative third power, well, that's probably just going to give me, or 1/10 to the negative third power is just going to give me a 1 followed by 3 zeros. Yeah, Mr. Claxton, don't like that either. I might be able to plot 10 to the negative first, so I'm going to come all the way down here. Mr. Claxton, quit saying 10 to the negative first. It's 1/10 to the negative first. You know that. And so do you. You people who are watching at home. 1/10 to the negative first power, and this truly does mean that we can just flip it. Flip it good, right? There we go. 10 to the negative first. The same as 10 over 1 raised to that first power, because I can make that a positive exponent now. And alright, we've got something to work with. At -1, we can go up 10. So -1 and up 10. Well, Mr. Claxton, it stops at 6. Well, 7, 8, 9, 10. You know what? I'm going to go ahead and extrapolate that. You know, extrapolate's just a big word for extend. I'm not even sure I used it right. So we'll have to define that in class tomorrow. So let's go ahead and 10 to the 0 power. Well, Mr. Claxton, I know any value raised to the 0, or here I go again. That's 1/10, everyone. 1/10 raised to the 0 power is 1. I know that. Boy, that's nice. Nice point there. Now, what's going to happen whenever I start these positive values? I'm going to go ahead and draw a little arrow out here to show you my work for this one. I have 1/10. Notice how I keep writing it as a fraction, because you know what? Sometimes fractions actually are easier to understand. 1/10 to the first power. Well, you know that's just 1/10. Well, 1/10 I could write as 0 and 1/10. Okay, so 0.1. I know that's going to be, well, very, very close to, but not touching. I think that's a pretty good plot right there. I don't even want to consider 10 to the third. I just want to say, okay, I'm going to look at, we're going to look at 10 squared. And I keep saying 10, but every time I say 10, you just know that Mr. Claxton means 1/10, right? 1/10. I know that you probably keep laughing at me, or pulling your hair out, one of the two. So 1/10 raised to the second power. I hope you're not pulling your hair out. You need to appreciate your hair, right? I am a case in point. Later in life, you definitely appreciate your hair. So 2/100. Mr. Claxton, why did you even graph that? You might be asking me, why did you even graph that? Because that's not right. That's not right. You just get so concerned with making jokes, and hopefully you caught that right away. That's not right. That needs to be 1/100. So the important thing about a mistake, ladies and gentlemen, is that we acknowledge it, and then we move on, right? So that's 0.01. Oh, Mr. Claxton, why did you even do that? Some of you might even be saying, why did you even graph that point? Well, just to show you how close that gets to 0, but it never really touches it. So I'm going to try a different strategy this time. We're going to come down. I know that that's going to pass through points. Okay. And then it's going to shoot straight up. And where's it going from here? It's going straight up here. So let's go ahead and give this a shot one more time. And you might say, Mr. Claxton, that looks like a straight line. It's not a straight line because of that curve right there. Okay, we're just going to make that point just a little bit bigger to include it there. Okay, so you can see how this is called decay, because from left to right, it starts falling, and it keeps falling. Forever and ever and ever. It gets closer and closer and closer to the x-axis. Alright, well, that one took a little bit longer than expected, but hopefully you understand what exponential decay is now.